Hey guys, welcome to this new class in the course of Aerospace Engineering, Aircraft Systems and Avionics. Now today we will continue to study the electrical system, and specifically we will be talking about the power distribution. Right, so in terms of the power distribution, again what we see is the schematic that we've seen in other classes with all the area regarding the alternating current and regarding the direct current, okay? The transformers, the generators, and also the different buses for the different users. Right, so the first thing that we need to do now is define what is a bus. Right, so an electrical bus connects the general electrical circuit in an aircraft to all the subsystems which require electrical power. So that means, you know, any screen, any electrical device on the aircraft needs to be connected, you know, through a bus to the main generator system, right? To the main electrical system. And this is the, you know, the visual concept of a bus, okay? Meaning that what we do is connect this bus to, you know, to the electrical system, to the generic electrical system, and then we can simply connect all the devices, all the different users that we need, okay, to the bus, right? So this is the idea of the bus. Right, so this is the schematic again, as we've seen. And just to go quickly through this, we have the alternating current bus, okay? Number one, number two, in fact. We have the direct current buses, okay, over here, which is the DC bus 1 and DC bus 2. Again, remember that we're using the first system and the second system related to generator number 1 and generator number 2 on different engines of the aircraft. Then we have the DCESS bus, or what is known as the emergency bus, okay, which is a bus that will be used in the case of failure of the generator number 1 or generator number 2, okay. Then we have the alternating current essential or emergency bus. And finally, we have the hot buses, okay? Hot bus number 1 and hot bus number 2, which, you know, the idea of a hot bus is that it always is powered, okay? Any energized bus will be hot, okay? Any of these buses will be hot at some specific stage, but the common use of a hot bus, okay? The idea of a hot bus means that it doesn't need a switch to be powered, but rather it simply comes directly from the power source, right? So a hot bus is really a powered bus, but the term is usually described specifically for a bus that can't be powered down, okay? So the hot bus will always be connected to some kind of supply of energy. And this is extremely important in the case of aircraft, right? So again, we have just generic alternating and direct current buses, 1 and 2, depending on the system. We have the essential emergency buses, okay? And finally, we have the hot buses. So this is the definition of all the buses, right? Of all the different connections that we need in order to get energy, electrical energy, to the different subsystems that we need. Right, so this is what, you know, if you are a pilot, this is what you will see. And this is the way that you can visualize the different systems, you know, of the electrical power, right? So, for instance, what the generator is doing, if it's working, if it's not working, if it's operating, okay? You can also see the different buses, right? The DC1, DC2, AC1, AC2, with the voltage and intensity, the current of the, you know, if it's working, if it's not working, basically. And then you have also the AC emergency and DC emergency buses over here, which indicate again the operation of them. Also, we have the APU generator, which we mentioned before. And the batteries and the state of the batteries. Okay, so this is the, you know, a bit of a summary of all the different systems, how they are operating and their current, you know, conditions. Okay, so this is what the pilot will see, and this is how a pilot is able to identify all the subsystems if, you know, their operation generally. This is in the case of an Airbus A320. For most aircraft, you will see something similar to this. It may vary a bit depending on the aircraft, okay? Right, so yeah, I wanted actually to mention a few more things on here. Okay, so a bit of the strategy in terms of the alternating current and the DC current and also the emergency current. What's the main difference and so. Right, so the AC and DC ESS buses provide power to critical instruments, communication and also navigation equipment, okay? So the AC ESS bus is normally powered by the AC bus number 1, right? And in case of the AC bus 1 failure, in case of that this fails, okay, the AC ESS bus can be manually transferred to the AC bus number 2 by selecting the AC ESS feed over here, which is a switch that the pilot can actually alter, okay, on the overhead panel. Right, so on aircraft that are modified with the addition of an automatic switching system, which this could be, just means that this could be automatic, okay, the switch should not need to be pushed in the case of the failure of the AC bus 1. So this is a bit of the strategy used, okay? There's many types of different strategies and algorithms that define when an AC ESS bus is working or not, okay? And in the case of the DC ESS bus, is normally powered by the DC BAT bus, okay? So the battery bus. Right, so this is the battery bus over here, okay? It can also be powered by the ESS-TR, and also, it should be powered by the ESS-TR, okay, in the case that the TR1 or TR2 fail, okay? So it basically comes to mean that depending on what fails, if there's some failure on the engine, for instance, we of course, if the engine one doesn't work, then we have troubles regarding the generator one, we have troubles regarding to powering all the subsystem on this number 1 area, okay, and so we basically need the generator number 2 to fulfill all the different subsystems, okay. And the way in which this is done, it changes from aircraft to aircraft, but basically you can see that there's always a strategy to make sure that all buses are covered, right? Okay, so again, the most general used conductors are copper and aluminium, okay? Each has characteristics that make its use advantage under certain circumstances. Right, also each has certain disadvantages, okay? So copper has a higher conductivity, for instance, is more ductile, has relatively high tensile strength, and can be easily soldered, okay? Copper is also more expensive and heavier than aluminium. Although aluminium has only 60% of the conductivity of copper, okay, it is used extensively. Its lightness makes possible long spans, and its relatively large diameter for a given conductivity reduces the corona, right? So this is the discharge of electricity from the wire when it has a high potential. Okay, this is a bit technical, but it's actually an advantage, okay? So the discharge is greater when small diameter wire is used, right, than when large diameter wire is used. So it's always a balance on the weight, and it's a balance on the amount of conductivity that we have on the type of conductor, okay? In the case of the design of an aircraft, you just have to take into account usually the 2 possibilities using aluminium or copper, and you should also take into account the technological inconvenience that might be related to each one of them, okay? Now, bare copper develops a surface oxide, okay, coating, at a rate dependent on the temperature. Now, this oxide film is a poor conductor of electricity and inhibits the termination of the wire. Therefore, all aircraft wiring has a coating of tin, silver, or nickel that has far slower oxidation rates. Now, this is essential, okay, in order to make sure that all the cabling in an aircraft can operate without problem, okay? This is something which is simply needs to be done, right? Okay, and in terms of insulation, the type of conducting insulation material varies with the type of installation. Characteristics should be chosen based on environment, such as abrasion resistance, arc resistance, okay, corrosion resistance, and many more. And really, such types of insulation materials are used commonly okay, are PVC or Captain, for instance. But again, these are not longer used for new aircraft designs, okay? So mainly what we have nowadays is for new aircraft, okay, we have these technologies which are the TFCL, Teflon, Captain Teflon, and also the PTFE, polyimide, and PTFE, okay? It's a bit more advanced and has, you know, better qualities than the most traditional technologies or insulation materials that we had before, right? Now, with an increase of the number of highly sensitive electronic devices found on modern aircraft, it has become very important to ensure proper shielding for many electric circuits, right? So shielding is the process of applying a metallic covering to wiring and equipment to eliminate electromagnetic interference. So basically what we actually prevent, you know, by using a shield, what we're making is the cable, the wiring, electromagnetic free in terms of the electromagnet, you know, the interference that could come from other sources, okay, independent of the cabling. So basically what we're doing is kind of shielding the cables from the surrounding electromagnetic fields, okay? Right, so this interference is caused when electromagnetic fields, as I said before, maybe sometimes also radio waves, induce high frequency voltage in a wire or component. Of course, this should be, you know, this would be a problem in our cablings, and the induced voltage can cause system inaccuracies or even failure. Okay, so basically we also need shielding for all of our wiring on aircraft. Right, so what else? Yeah, this is a bit of a schematic of the whole system, of the electrical system, okay? Many users we have are the Avionics. We also have them, you know, here we have the DC power distribution bus, okay, which is over here. Again, we again have the generators on the engines, as we mentioned before. We have the three-phase power converters over here, just close to the generators, okay? And then we simply, you know, we have a DC power distribution bus all through the aircraft in order to make sure that the different users, okay, so the different subsystems that use electrical power can be powered without problem, okay? And finally, I just wanted to mention, this is, I think I haven't mentioned it in the course, so I just wanted to make a brief description of what the ground unit looks like, okay? So this is basically when an aircraft is at the ground, we don't have, of course, the engines are not operating in a rate which are able to provide electrical input to the aircraft. So we simply connect, okay, the aircraft to a supply, a generator supply from the ground, okay? So this is all for this class. Let's go to the next one.